Perfect. The title of the talk is Tackling Component State Reactively. And I will start the whole talk with a quote from the Gang of Four. If you stick to the paradigms of object-oriented programming, the design patterns appear naturally. And I want to stress the bold part a little bit more. The patterns appear naturally. What does it mean? It means they did not really put in a lot of effort to discover something new, a cool pattern, or improve something with a lot of effort. They just stick to the paradigms, in this case of object-oriented programming, and their patterns appeared naturally, effortless. This quote was basically my whole motivation for all the research on reactive component state and also on all my other findings and creations based on reactive component state. And to give you a little bit of an overview of what I want to talk about in the next 30 minutes is terminology and categorization. So I will introduce a set of terms and categories that will help us to understand all the problems a little bit better and also see what tricks I needed to implement. The second thing is I will discuss a certain set of problems and their solutions. We will see a lot of live demos and I will discover why laziness in state management is essential for a set of other really cool performance features that build up on top of reactive lazy state management. First of all, layers of state. I thought, as we talk so much about state management, let's start by categorize the layers of state themselves. And on the very left side, the dark blue thing, there is the server state. And here I pictured two database concepts, relational databases, object-oriented databases. Of course, there are also graph databases and so on, but they live on the server. This is my server state, very persistent state that also survives the duration of any client-side application or any other things that consume this state. Then on the other side, I have the client state. And to make it a little bit easier, I subdivided client state into persistent state and into ephemeral state. Well, persistent state is, I guess, a term that we may know from the term global state, but persistent state and global state are pretty much the same. And we have a set of already existing tools for persistent or global state. In the Angular ecosystem, for example, there is Ngrx, Akita works pretty much for any front-end framework, and ngxs is also a little bit more dedicated to the Angular ecosystem. And on the other hand, ephemeral state, there is pretty much not a lot out there. Some front-end frameworks already implemented their state management in components in a very fundamental way. But the concepts and, of course, the tricks and the stuff that I introduce are pretty cool and applicable to pretty much all other frameworks too, even if they have their own tiny component state management inside. So what does ephemeral mean in ephemeral state management? Well, ephemeral is basically something that does not really last for a long time. And if we look at this picture at the very top, we have global store, browser plugins, URL, those things, they are like always present, always available for all my components in my application. This is like my global layer, globally accessible sources. And then I go a layer down into my components tree, where I have here two components, and those two components derive their state from this global layer. Of course, these components also manage a set of subcomponents, and they lead a little bit more data from their surrounding. So the small yellow helmet here marks the area that I want to talk about. This yellow helmet marks the area of the ephemeral state that is composed out of global sources and local sources, and that is only relevant for this very component. In this case, either for the list component or for the chart component. Let me introduce myself quickly before I go on, because we only have a very small time slot for this talk, so I will not really spend a lot of time on this unnecessary stuff. My name is Hladky. I'm lead instructor at Trilon. I also do consultancy, trainings and workshops on-site and remote. If you feel that my content is helpful or you like how I teach it, feel free to contact me. Let's go back and start through with terminology and categorization. And the first categorization, or the first way how I try to differ global from local state, is the first question about accessibility. Is this state that I want to manage globally accessible and shared through multiple parts of my application, or is this state locally accessible and shared only within a very small scope of a component, which gets created and destroyed over time, one or multiple times? The second question that I ask is the question about lifetime. We have on the one side static lifetime, and for example, our browser search bar has static lifetime. This search bar exists before my application starts and after my application ends. Versus an example for dynamic lifetime is when I have a certain snippet of template which I can hide or display, and inside of this snippet there is a certain state. So this snippet of state gets created and destroyed, in best case, whenever I hide or display this certain part. And this is a very good example for a highly dynamic or ephemeral state piece. And the third question that I ask is, what are my processed sources? While with global state management, I process mostly remote sources. I process the URL change, I process the result of HTTP requests, I process WebSockets, browser plugins like the Bluetooth plugin or whatever, and I merge them together in a global piece of state. And then on the other side, I have the local processed sources. So when I manage ephemeral state, I barely process any global sources. Of course, maybe I can retrieve a list or some other tiny slices from the global state, but mostly all the interaction is coming from click events, scrolling, child components that emit their state that I have to manage, maintain, and merge into my own state. And this is pretty much all locally. And those three things is, I guess, a pretty cool set on how to discover and figure out, is this state slice that I'm dealing with a global or a local state? The first problem in the set of problems is subscription handling. As we have a component-oriented frameworks and components get created and destroyed over time, there is the question on when should I subscribe and when should I unsubscribe? Where the question for the unsubscribe event is pretty much clear, at least before I destroy my component, I should unsubscribe, but the subscription is not that clear. If we look at this diagram, we have at the very top the life cycles of a component. In this case, these are the life cycles of an Angular component, but any other front-end framework has their own life cycles and they are pretty much the same. The ng on destroy or unmount life cycle, the destruction life cycle hook of any other framework is always present. So this can be mapped to pretty much everything that is out there at the market. And in this very diagram, I subscribe when I construct, when I create, initialize my component, and I unsubscribe when I destroy my component. This is like the way I suggest that we do it. The question is, how can we do it in an elegant way? And if we take a look at those two code snippets, and we start on the left side, we see that there is the ngOnDestroy lifecycle hook or the onUnmount lifecycle hook. And this lifecycle hook feeds a subject that is called onDestroy. And if I next this subject, within my hold function, we see that there is a take until that listens on the emission of this onDestroy subject. And whenever this subject emits, I unsubscribe. From what do I unsubscribe? I unsubscribe from an observable that is passed over the hold function. And for those who know Angular, you maybe take a look at the first line. This is not a component, this is a service. So also our services have lifecycle hooks in Angular. If we know this, we can leverage the fact that services have a lifecycle hook by using them as local provider. If we look at the right side, I provide this service locally in a component, which means this service gets created and destroyed within the same lifetime of a component, which is pretty cool because the lifetime is identical. I again have the ngOnDestroy hook, and I can basically leverage this service layer to do automatical subscription handling, which is pretty cool. As a quick demo, I don't want to demo too much at the beginning because I have a lot of different demos that I want to save for the end. But here, a very small and quick one. If I go in the right folder and I quickly demonstrate how we could implement this pattern in real life. Let me quickly go here to state and then to my subscription. I can quickly demonstrate that this component is done without this technique. So I have to implement a couple of different things. I would have to implement the ngOnDestroy lifecycle hook. I would have to implement a subscription here that can basically handle, basically handle all the stuff, and then I would have to assign something to this subscription whenever I want to listen to a certain thing, for example, to a certain process, and then I would have to pass my callback here. Also, I would have to implement the onDestroy lifecycle hook at the very top, and then I would have to unsubscribe from my subscription. So if I do this, we see that I have to implement a couple of lines of code. If I stick with my service implementation, which is already present, I can get rid of the lifecycle hook, I can get rid of the subscription, I can get rid of the call, and I can also get rid of handling the life cycles. So we are down to one line of code and the usage of a certain service, which is basically, I guess, 7 lines less. And the cool part, we don't have to be afraid to run into any memory leak because we don't use the word subscription here directly. We just hold a certain process, subscribe to them in the service, and we, as a consumer of this helper service, we don't need to know about what's happening under the hood, which is pretty convenient, and we can save a lot of lines of code. The next thing that I want to talk about is state selection and memoization, what to share and what not to share. And the first slide that I want to discuss here is a slide that compares unicast versus multicast observables. This is essential when we select or derive state. And I want to discuss it here in a little bit more theoretical way and then switch back to a practical way. So on the left side, we have unicast, which means if I have an observable and 2 operators, a map and a filter operator, and I subscribe to this observable one time, which is the first orange diamond here, and later on I subscribe a second time, we see that the small black gears here, the work that is done, is executed 2 times, 1 time for every subscriber. If we go to the multicast side, we see that I added another operator, a share operator. And What is the share operator doing? The share operator basically says, if you subscribe to me the first time, I will subscribe to all the other upper operators, and then I will manage and hold this subscription for you. And when a second subscriber arrives, I will just forward this subscription for the second one and don't resubscribe a second time. Which is pretty cool if we want to do some work. For example, if we want to calculate heavy things. Another interesting thing, and this is a way more tricky example, which I display here, is if we create instances on the fly. Let's say we have some incoming values, and those incoming values are basically the credentials to create a specific object, for example, a form or something else. And if I would derive it and subscribe 2 times to this form, I would create the instance of this form two times. I would have 2 different instances of this form. Same as I would execute work 2 times. And this is tricky because if we now are in a component and we subscribe to this stream that produces us the form, we subscribe 2 times and we get 2 different instances, and our components are not working. Versus, I apply on no matter what derivation a share replay operator. Then basically every subscriber, so the first subscriber will initialize it, and every other subscriber will basically get re-emitted the last created instance. And this helps us to get away with a lot of tricky problems, which I can demonstrate you here in a little bit. I have a form, and this form is basically not working. I will quickly click here on this selection, and we see that this is an input box, 2 input boxes, and if I type the values updates in this specific part here, but this null, if I zoom in a little bit, this null here tells me, okay, I don't realize that the form has any changes. And why is this the case? This is the case because in my code, and now I really jump to the particular part, I basically create my form and then I subscribe 1 time to notify parents over changes and a second time in my template. And those 2 subscriptions basically create 2 different instances. If I now want to fix it, I have to apply the share replay operator. And if I do this and I apply the share replay operator to whatever state I want to derive, and I switch back to my example, I should see that first of all the page refreshes, and after the refresh is done, I could type into this form field, and we really see that we are now able to receive the changes because there is only this 1 single instance that helps us to retrieve the state. So no multiple instances created. Back to the slides, as we have pretty much no time. And I want to go to the next and maybe the coolest and most trickiest problem. State composition is cold by default. We rely on the consumer, and the consumer basically initializes whatever composition we run. And to understand this, let me first talk about how we do it wrong. Normally, people tend, if they, for example, receive values over services and later on want to display them in a component's template, that they apply a share replay subject or a share replay operator. Because they say, well, my component is late, I have already some emissions, I missed them, and I just re-emit the last emission if the first subscriber arrives. Well, if we do this, it will, in many cases, fix the problem, but we overlooked a very critical problem. We overlooked that we will miss values. If we have composition running, and in this case it is just a scan operator that accumulates or increments values, we basically realize that we will lose the first 2 values in this example, because the consumer is under control of our state composition. So what I suggest is that we switch the whole process and we hand over the control to the producer. So what we need to do to achieve this is we need to make the producer a hot source, to have the composition of the producer hot. And this is done by applying publish replay. Publish replay is a special operator that if I call the connect method on this connectable observable, it will start immediately, even if there is no subscriber present. And it will calculate, process, and accumulate all the state. Later on in time, if my component template is ready and subscribe to it, it will just receive the correct state, no losses, nothing. This is a pretty tricky problem and a pretty good implementation to solve it, because we don't push workload to multiple others. Let me quickly jump into a demo case, and if I open here my experimental demos and I go to composition, we see that if I enable the checkbox, I see a counter, and this counter is basically my state accumulation. I will zoom a little bit in that we see the number here ticking, the number is incrementing, so I hold a state of one number and increment it over time. And if I hide it and show it, I keep the state. So it is not lost, no matter if I hide or show it. If I would remove all my state handling and I would go here into my parent component and switch to a hot composition, which should be present here, I basically do the same thing. I just connect my source, my composition 1, which is basically just accumulating this very number here, and I will not lose any state. So I could get rid of the share replay here, which is basically missing all the initial values because we started with 0, and I connect it. And then I take this hot composition source and I use my hot composition in the template. And if I now refresh the page, and it will take a little bit of time, there is no value visible. I wait for a certain moment, 1, 2, 3 seconds, and I start, and we see that I immediately started with 7. So if I refresh the page, now nothing is present, but still I am able to calculate, to process certain state slices already. And now if I click the visualize button, we see that there is already state computed and my template is not under control of the composition. Versus in the previous example where we always started with 0 when I displayed this snippet of code here. Back to the presentation. So subscription, less interaction, and this is also, I guess, a really cool part that I can discuss in the last 7 minutes that are left for the talk. Subscription less interaction was the one problem. When I solved it, I was most happy about it. What's the problem? In many cases, people tend to manage their state with a behavior subject. And okay, it is possible, but believe me, it is a clutter. If I can show you how you could work without a behavior subject, and especially without using the word subscribe, you would go crazy and immediately start to use those techniques. So be ready and focus on what I'm trying to explain. In this example, I have 3 different state slices. I have my global state, I have the browser URL bar or the router state, and I have some input bindings from parent components. To handle the composition of all those state slices, I have to subscribe to all those state slices and use my setState method displayed here, where I basically next a value in my subject. And then I would also have to take care about subscription handling, and I have to paste and take until to this function to basically unsubscribe from it, which is a lot of code for just composing 3 different streams, right? In fact, it is not only a lot of code, it is a clutter because we break the reactive flow. Whenever we use subjects and call the method subject.next, we basically break the reactive flow, stop our reactive functional thinking, go back to imperative programming, use a setter to use another subject and call their next method, which in turn gets again transformed back into a stream. And this is not really necessary. In fact, it introduces a lot of different problems into our application. So what's the solution to this problem? The solution is I'll use higher order operators. I will use the OR operator, the merge OR operator. And what the merge OR operator does is the merge OR operator takes an observable of observables, internally subscribes to all of those observables and merges their emissions together into one single output. And this is pretty much the coolest trick that you can do to connect different observables. If we do this, our whole chain is not broken. We always stick to the reactive programming style, and we reduce the number of lines a lot, and we reduce the number of potential problems a lot. If we compare the lines, if you can see, at the moment, we only call this connect state method. That's everything we need to do. And we pass the observable. There is no take until, there is no subscribe, there is no maintenance of the subscription, there is no unsubscribe, which is pretty amazing, I would say. I could demo this, but I want to show you some more demos in the last 5 minutes to see how cool you can leverage it. Just to remember the concept that I started with, sticking to the paradigms of, in this case, reactive programming, and the design patterns appear naturally. I basically sat down after solving all those and multiple other problems and tried to combine them in a reasonable way. And the output is called reactive component state in Angular under the name Rx Angular/state. This is, of course, an Angular dedicated service, but believe me, I only introduced 2 lines that are Angular specific, which is the lifecycle hooks. And the rest is framework agnostic. And many people already came to me and said, well, they copied the service, they removed those 2 lines, adopted them to their specific framework hooks, and it works like a charm. So what is it? This service will help you to go from a very confused architecture in your application to first a structured architecture in your application and then a performant architecture in your application. It is a very easy interface that helps you to connect and select reactive state slices, and also provides some options for imperative programming with the set and get method, which you can use to imperatively glue other pieces into this state management. At the bottom, I have my hold method, and at the top, I basically have the $sign that tells me that I will not select a sub-slice, I will select the full state slice. Okay, then we have the interfaces, and the interfaces are identical to the simplicity as the API naming. My interfaces take always a partial T and return always a partial T, where T is the state that I want to manage. So pretty easy to understand and pretty cool to maintain. Let me quickly show you how I would leverage this implementation in a real component and basically glue some nasty parts together. Maybe for this small demo, I wanna start with the most nastiest thing that I can think of, combining imperative methods together with reactive methods. And here, in this component, I have an input binding. And this input binding is basically not composable. So what would I need to do to compose an imperative method into my reactive state management? I can leverage pretty cool tricks. First of all, I have to, I could extend it because it is just a class. I don't like extension, but I can basically try to do it here, extend Rx state, and then I basically have to type it with my component state. So that's it. Now I have a component that maintains reactive state that I can access. And now I can go here and I can think of how could I get rid of these lines of code here and make it a little bit more reactive. Well, the easiest approach is I delete my lines here, and as I have my service now reactive, I could say set. And I can now decide to set a specific value. For example, in my component state, there is a refresh interval that refreshes every n milliseconds a component. So I could place this value here and then a key value pair. As the key value pair is, the name is the same, I can do the shortcut, and this one-liner would basically help us to connect incoming values from my input binding with the state. So I could also get rid of this. Even cooler, as we know that when a value arrives in my input binding, I trigger a state change and I re-render the component. We could try to get rid of this unnecessary re-rendering by passing an observable of number instead of a number in a static form. So how could we implement this if here? Well, pretty easy. I could say this, and I can connect a certain observable. In this case now, we receive an observable of numbers here to a certain state slice. What is the name of my state slice? The name of my state slice is refresh interval. And this is the observable that I want to, whenever it emits a value, update this state slice with the new value. And as I have a if condition here, I could basically use a filter method that helps me to filter out all the values that are smaller than 4,000 milliseconds. And then I can also get rid of this. And this tiny slim one-liner here helps me to connect to receive values from an observable, filter out some values by condition, and assign those values to this property. Pretty cool. Two ways how to connect imperative or reactive state. Back to my slides, and there are only a couple of slides left, I guess 3. And I want to answer the last question in this very quick talk here. Why did I spend so much time to make my state reactive, and why did I spend so much time to make my state lazy? Because I could also implement all this stuff in an imperative static way. Well, pretty cool. If my state is reactive, I have the values push-based. So with this push-based thing, I can leverage a certain context. I have now the context of the next value, an error, or a complete channel, which we already know from RxJS. And then with laziness, and the trick that I did to have my state management lazy, because any other state management is basically eager, they immediately emit your initial state. I don't need any initial state, by filtering out undefined values. So if there is some undefined state slice, I just don't emit. And with this trick, my state selections can be lazy, and if my state selections are lazy, I could get a new fourth state into my reactive context, the suspense state. And now I can have a state slice which has 4 states: the state itself, the suspense state, the error state, and the completion state. And why did I put it so much time? Because from the beginning, I was thinking about a specific package that brings laziness into the template. And the outcome was high performance rendering with Rx Angular / template, where I basically, while introducing reactive lazy state in my component, I was able to bring laziness in my template, and therefore I was able to create a package that ships a variety of template helpers that maintain 4 states in one single helper. And you can have a loading spinner, an error message, and a lot of other stuff in one single piece of code, which is incredibly cool. To end up the talk, and maybe if there is time, as we started earlier, Jen will maybe inform me if I should go on with some more questions or other stuff, but if there are no other questions left, the slides will get published online. My research on component state management is linked here at the top, and the GitHub repository for the whole 2 different packages, the reactive state management package and the reactive rendering package, which basically now introduces 4 different reactive states into your component and therefore leverages some less performance in some full Angular applications and lazy performance and laziness in rendering in pretty much any other framework, is linked at the top under github.com/rxangular. If you liked the talks, read up the research document. It is for every framework. And if you want to share a little bit of motivation for the contributing team on this library, give us a star on GitHub.